This was a presentation I performed at the World Congress Tectonics Facade Conference, and the following year I presented it in Bern, Switzerland. The session was well attended by professionals around the world, architects, engineers, and researchers from universities. It was a design-build competition. Design architect was Johnson Favreau, and you've got Johnson Favreau's buildings at Trade Tech on the south side. We won the competition because I came up with a unique idea of an active double skin facade. As you know, the majority of the points are in the atmosphere and energy category. Now, air itself is a great insulator because the molecules are very far apart. It's not like metal, which are right next to each other, so you can conduct heat, but air is a great insulator. A double facade, a glass vitrine that sits directly on the civic ground, providing openness and transparency. The public walkway flows directly into the building without a threshold, unobstructed views to the sea. With everything exposed, it provides sparks of curiosity and a great learning opportunity. During the day, it's great to see out, and at night, it's great to be seen. There were two solutions. The first was based on natural buoyancy. Or hot air rises, it's buoyant. At the base of the building, you can see a 6-inch high grille at the perimeter base of the building. It would draw cold air, and the glass would heat as the sun rises, and it will also heat the air between the two facades. The chimney effect would allow preheated air to the air handling units and heat other parts of the building that needed heat. Should during the day the air got too hot via sensors, then it would be rejected. We analyzed the air temperature on different facades. We were able to calculate the temperature at the top of the facade for different aspects. We examined the chimney effect for different months of the year. This is a detail of the grille. However, the design architect would not accept the solution. The second option, a thermal blanket. Let's look at each stage, starting item 1. By code, each person must be provided with fresh outdoor air when it's brought into the building. Then we also have an equal amount of air being exhausted. Otherwise, the air would be heavily pressurized and the doors on the outside of the building would be left open. This air is conditioned at 72 degrees. Item 2, exhaust air is returned to the mechanical room. Item 3, variable speed fans accelerate or decelerate the air flow depending on the temperature reading at each of the facade. 4, provide a thermal blanket, an active double skin facade. To verify this, we need science. We performed a 3D dimensional computational fluid dynamics model. In the x-axis, on the y-axis, and on the z-axis. Total transparent building with a high performance, minimum roof profile, thermal blanket, and seamless threshold equals open access. We examined different glass types. Structure of the glass. Detailing. You can see a 2-foot space between the two panes of glass. This is the air barrier. This is the insulator. More details. Connection details. One can see there is not a threshold. Manhattan Beach is a world center for surfing. The ceilings and millwork is what they used to make the old type of wooden surfboards. The architect used that for the ceilings and the millwork. View out of the second floor. More views. You can see the ocean. Opening day of the public library. You can see the setting of the ocean and the sun setting on the side of the building. If you look on the right-hand side, you can see as the sun goes down, it's as a mirror finish. And on the other side, as you're looking to the building, you can see the transparency. You can see the great photo of the library.